In this lesson, we're looking at the scalar dot product. Essentially, scalar dot product is the scalar, which really just means numerical. So it's just a number, product of two vectors in the same direction. So this may mean that we're looking at components of vectors that are relating to each other. So let's say if we've got vector, so let's say we're looking at vector A and vector B, the scalar dot product would be the product of the magnitudes in a common direction. So this one here will be the projection of A in the direction of B. It will be the product of this magnitude and that magnitude. All right. So essentially there's two rules. One rule when in component form and one rule in polar form. So the dot product A dot B will be the product of each of the relative components of A and B. So A2, B2, then all the way up to AN, BN. Now, because we're only working in 2 and 3 dimensions, for us, this will simply be A1, B1, A2, B2, and A3 by B3. And if we look at this as a quick example, if A is 1, 2, 3, and B is 2, -1, 3, then A dot B is 1 by 2, 2 by -1, and 3 by 3. That's the sum of those three products. We have 2, take 2 plus 9, so our dot product is 9. Okay, so this is a dot product when in component form. Now, if we have two vectors in polar form, then the dot product will be the magnitude of A multiplied by the magnitude of B and cos of the angle between them. Now, this is important. This is the angle between the two vectors. Okay, so as a quick example, if we have vector A, which is 2 and 30 degrees, and we have vector B, which is 3 and 90 degrees. So these two vectors, magnitudes, the angle between them would be 90 degrees, take 30 degrees, which would be 60 degrees. And the dot product of A and B would be product of the magnitudes, and then cos of the angle between, so cos 60. So we get 6 cos 60, and cos 60 is 1/2. So we end up with 3. So the dot product is 3. So these two things are the same. Again, it's just different ways to do it depending on the form of the vectors you're working with. Okay, so we've seen two simple examples calculating the dot product. Generally, the dot product is used to determine the angle between two vectors, or to look at the relationship between two vectors. So we need to be able to use that scalar dot product to be able to calculate the angle between two vectors. In order to do that, we utilize this form. So A dot B is the product of the magnitudes and then cos of the angle between. Now, generally in this scenario, you'll be given the vectors in component form. So let's say that A is equal to 1i plus 3j, and B is equal to 2i take 5j. Okay, so we've got two vectors there. Now, if we want to find the angle between, we want to be able to isolate the cos of that angle and then isolate the angle. So if we first divide by the magnitudes of A and B, we get the dot product of A and B over the magnitudes of A and B. is equal to cos theta. So the cosine of the angle between is the dot product over the magnitudes. If we take the arc cos, we get the angle is the arc cos of the dot product over the product of the magnitudes. Okay, so nice and simple to isolate that angle. Now all we need to do is perform these calculations. So the dot product will be the product of, or the sum of the products of those directional values. So we'll have 1 times 2 and over the magnitude of A, which is 1 squared plus 3 squared, and the magnitude of B, which is 2 squared plus 5 squared. We've got arc cos of 2 take 15, which is negative 13, and square root of 10, square root of 29. So the angle between the two vectors is, which means 139.76. That's a quick introduction and a couple of examples with the scalar dot product.